So the derivative of the function is fx is equals to x over x plus 1. So the function is this one, and the condition, we have to use the first principle of differentiation. So the first principle of differentiation for f of x, f of x prime, limit h tends to 0. I mean, by the definition of the first principle of differentiation of any function, so that function's first order differentiation is equals to limit h tends to 0, f of x plus h minus f of x over h. Now the function is x over x plus 1, so limit h tends to 0, so it will be x plus h as the function of x plus h. That's why plug in instead of x will be x plus h over x plus h plus 1 minus x over x plus 1 h. So h tends to 0. Here the LCM will be x plus h plus 1 times x plus 1. Here x plus h times x plus 1 minus x times x plus h plus 1 over h. Limit h tends to 0. So here will be h and here will be k. So it will be x plus h plus 1 times, and if we multiply, so the result will be x square plus xh plus h plus minus xh minus x. So let's use the different color pen. So minus x square cancel out, xh xh cancel out, this one and this one cancel out as well. So we have, so it will be limit h tends to 0. So here will be x plus h plus 1 times x plus 1. Here it will be h, just h left here, and here will be h as well. We know that a by b over b by c. So here b by c is this h, and here a is h and b is this two terms or two factors. So if we simplify this one, limit h tends to 0, so that we could write down h over x plus h plus 1 and then x plus 1, and this h will be here. So h is cancel out, so we could write down limit h tends to 0, 1, x plus h plus 1 and x plus 1. Now this is the right time to plug in the value of h is equals to 0. So 1, here x plus 1 and here x plus 1 as h is equals to 0. So we could write down 1 over x plus 1 whole square. So this is the final answer.